Does that sound correct, everybody? Here's the expression of if, else, if, else, if. If expression, then do something. That something can be a whole block of code or it can be a single line. Else, if this expression is true, do something else. Else, if expression is true, do something else. And then usually it's good programming practice to end the whole thing on just a single else. Not an else if, but just an else. So that if none of these things are true, you can print out some kind of error message or something like that, an unexpected state message. Now you Python programmers notice that in Python it was called elif. E-L-I-F. Well, in C and Java it's else if. So, what we're going to do is there's a such thing as a switch statement, and we're going to kind of leap ahead and do some logic that sets ourselves up for a switch statement. So for our in class, what we're going to do is we're going to write a program where if you type in a letter, it converts it to a number by the old rules of the telephone keypad. You know, you type in an A, it counts it as a 2. You type in a C, it counts it as a 2, and so forth. It'd be cool to do the reverse, where if you typed in a 2, it would be an A, but if you typed in a 22, it would do a B, and if you typed a 222, it would do a C. Yeah, let's do that one. Nah, we're going to do it the way I said. Okay, so I was trying to spare poor Parisa the fact that she's going to do the same thing in C++ that we just did in Java. But think of what a benefit it is to do everything twice. Okay. I've done something wrong. I chose Windows Win32 rather than empty project. Okay, just call this one phone. Something like that. And then add a source file, phone followed by your initials or something like that, phone underscore JGT for me. Good old boilerplate. # include IOStream. And by the way, on the test question, somebody was correct when they said that the code that I had there would not actually work. There were more than one problem with it. One is that we hadn't included a string class in a place that required the string class to be included. And then another is I had include iostream.h, and I don't think that that was valid. So, good for you for noticing my problems. I needed to fix both of those. I need to go back and make sure I do that before I reuse that exam. But we are going to remember to include string. Using namespace std. Int main system, all of our boilerplate. Pause. Return 0. There we go. What we're going to do is we're going to ask the user to type in a digit, a letter, and then we need to let them escape out of it somehow. And I'm not sure what an escape key should be. Maybe we'll just do a good old-fashioned user query loop where we ask at the end if they wish to repeat. So let's do a while loop. Before we do the while, let's do this. Nah, let's go ahead and do a break statement. I can't help it. I like while true loops. There we go. While true. Cout, enter a char to convert. /n. Now we need to read that character in. Or actually, we're going to read in a string. We could probably read in a single character, but I don't want to. I'm going to do this a little bit more elegantly. String S's, and then let's read that in. CIN into the string. Now let's get that first character out, and then let's turn it uppercase. And the reason for that is that the telephone keypad doesn't care whether we typed in a lowercase or an uppercase. So our char is going to be called CH, and let's get the first character out of that string. So at position 0 out of that string. And then we want to take that and we want to convert it to uppercase. And I know we looked this up last week. I hope I remember. Is it just 2 upper? There we go. Yeah, we wrote a 2 upper for the string, but for converting the character, we're just using their 2 upper character function that they provide us. So we've read in the string, we've stored the first character here. We've converted it to an uppercase letter. And now let's check to see what that is. If character is equal to an A, or the character is equal to a B, or the character is equal to a C, and we need another character or string to hold our output. So before our if statement, I'm going to declare a string called O for output. So if it's equal to an A, B, or a C, our output is equal to a 2. Oddly enough, there are no letters associated with the number 1. And the reason for that is kind of obscure, but what these originally were used for were that prefixes for certain cities were equal to certain words. Like Midwest City's word was the word regent. So if you asked somebody what your phone number was, you'd say, oh, I am Regent 73411. And so Regent, you would type in a 7, and then an E, you would type, R, and then an E, and then you'd type in the rest of the digits that they gave you. So since no phone number was allowed to start with a 1 because that indicated a long distance number, then 1 does not correspond to any letters. And instead you have done things like, some letters that are equal to 4. Some numbers that are equal to 4 characters. So back in the old days when you were typing on your little Nokia to type an S and you had to click the 7 key 4 times just to get one S, that was kind of annoying. Probably could have been made a little bit better if that was ABC and that was D, E, F. Anyways, so that's why there's no letters for 1. That carried through, from whatever decision when the punch keys were way back when. Don't know when. 30s or something. So there we go. Now let's do an else. Else if character is equal to an E. I'm going to take the spaces out just to get it to fit. But you know what these look like, hopefully. Or if the it's spacing it out for me. Thanks. Or if the character is equal to F. Or if the character is equal... Wait, I skipped D. A, B, C, D, E, F. The output is equal to 3. And we may as well do one row more. Else if CH is equal to D, E, F, G, H, or I, G or CH is equal to H, or CH is equal to I, then our output is equal to 4. And I'm doing this goofy since string, these should be strings. I need to go back up. I'm surprised that it's not flagging these as syntax errors. That needs to be quote 2, and that needs to be quote 3, and that needs to be quote 4. And if none of those are true, then let's just set our output equal to that input character, like that. Okay, then let's print our output out. Cout character, quote, converts to, end quote, output, end line. I'm regretting a design decision I made up at the very top. I'd like to make it to where if they type in like a space, it quits, something like that, but I'm not getting a good feeling for how to do this. So instead, we're just going to ask them at the very end. Cout, run again, y/n. And then cn back into our string, which was called s. And if s is equal to a capital Y, no. If s is not equal to a capital Y, I did my outs and ins backwards as I'm prone to doing. The arrows go the other way. If s is not equal to a capital Y, then we're going to break. Now I need to end my loop. I'm going to put a comment there saying that that's the end of my loop. End while. Sure. I think I can just barely get the whole thing on. I hope that's not too small. If you need me to zoom it back in. Nope, I can't quite get it all on one page. But I can if I scroll down. There we go. That's good enough. Go ahead and run it and see if it works. I need to do the same. I probably have an error. Whoa, I lucked out. Okay, enter a character to convert. An A. Ooh. I just totally did that wrong. Run that again. Enter a character to convert. I wish it would maintain this information between days. Okay, there we go. A is a 2. Run again. A. Now let's type in a F. An F is a 3. Run again. Type in an H. And H is a 4. Run again. No. And it bails out. Now we could make this program cooler by letting them type in an entire string rather than just one character, and then building the output string. So if they typed in "I love C," then we would turn on, we would create a string that consisted of all the digits that corresponded with those letters. All right, I want to make sure nobody has syntax errors before we liaise on. I got some errors. Entry point must be defined. I'm seeing entry point. Build. Choose clean solution. Okay, the third one down, and then do rebuild. Build, rebuild. Where's that other code stored at? I'm going to
take this, I don't know where that is. Close that and come back over here, and paste it into that one, because that's the one that's actually inside this project. Anyways, fix it. Oh, string, maybe something else, string S. Oh, we've already got string O, not 0. Okay, cool. Type in A, run again, shift Y. Yeah. You can make that if Y not equals uppercase Y and not equal to lowercase y. I'll do that. Just a second. I'm getting tired of having to type uppercase y's, so I'm going to change my if statement down here to also support lowercase y's. So if s is not equal, tell you what, why don't we just check for n's? If s is equal to a capital N, or s is equal to a lowercase n, and we could just use that, to upper business, but that's just about as easy. Then break.
It's not letting me I'm changing what she did, but I'm still getting there.
Okay. Well, I see that you need a space between return and 0. I don't know if that's the only problem. Now let's give it a shot. Oh, cool.
Sweet.
Let's get these syntax errors. What's odd about that is that this line looks exactly the same. There's nothing else. Oh, single equals. Because double equals. That'll help a little bit. Let's try writing it again. More than zeros than we just saw, but there you go. Yes, sir.
Once we change the syntax search, we need the double equals.
Make these strings rather than characters because S is defined as a string. It's kind of confusing how sometimes we're using single quotes and sometimes we're using double quotes. The reason we're using single quotes up here is we converted the first character to a type character set with a 2 upper on it.
And it's also giving me something weird whenever I run it, so. Just do that. Do that.
Yeah. Oh, I started off doing this wrong, and I corrected it. So let me do it. So what I did is it set that string equal to the ASCII value of 2, which for now. There we go. I don't know if that single quote would work, probably would. If we type in something it's not expecting, we want to get say converted, because that's not supported yet. Anybody else? I made a mistake up there. I tried to correct it, but nobody saw me do it. So sneaky.
So one.
can turn this code into something that may look a little bit better to you. Or it might look worse. I can't guarantee which one you're going to like. But we're going to change this to use a switch statement. And the way switch looks is like this. It has the word switch, and then it has a variable here, which should be either an integer or something that evaluates to an integer, like a char. And then it has case, and then it has a statement, and really there should be a break after that. So here's an example. Their code says enter A, B, or C, and then they do CIN into choice, and then switch based on that choice. And if they typed in an A, case A, print out you entered an A, and then break. Case B, print out you entered a B, and break. Case C, see out you entered a C, and break. So we're going to modify our code to look like that. So I hope this isn't too hard to follow. Above our first if statement, do this, switch based on CH, and then put an opening brace there. Delete that closing brace. We don't want that closing brace. Then, change your if statement to look like this. I'm going to just make the change rather than read it aloud. Case A, colon, case B, colon. I said I wasn't going to read it aloud, and now I'm doing it, huh? Case C, colon. And if any one of those cases is true, we set O is equal to 2. And then we break. We want to break out of our switch statement. If the break's not there, it's going to keep going and do the things that are inside the next case as well. Now I'm going to modify the D, E, and the F, and the G, H, and I to look the same. I'm changing that if into cases. So the syntax is a case followed by a colon. And if you want to list more than one case, you can do that. Another case followed by a colon, and then another case followed by a colon. And then a line of code or a whole block of code, and then a break statement. And that thing that says else, we need to change that to the word default, colon. So that very last dangling else becomes default, colon. And it doesn't need a break because it's the last thing. And then finally we need a closing brace.
So on the case, until it hits break, you can just write whatever you want without any types of parentheses or anything.
Right. Maybe you want to put some parentheses, braces. Like if you're going to be declaring other variables and stuff like that, it might be a good idea, int x, while x, is, that kind of stuff. You can put the braces if they will help, but you don't need them.
You don't need, okay.
Right. If I left this break statement off, here's what would happen. I'm just commenting this out. Don't do this yourself. If CH was an A or a B or C, it would print O as, well, it would set O is equal to 2, but then it would fall through and also set O is equal to 3. So without break statements, you have fall through, where it'll go into the next case and do the next thing as well. And that's just a consequence of the way that the switch statement is implemented. It's very rare that that's what you actually want to do. But if it is, then you put a comment. You put fall through so that the next programmer who comes up behind you
doesn't think you made a mistake and add a break there. But we want our break there, so I'm going to take all that out. Okay. Once you get all your case statements in there, it should behave the same way it did before when you run it. Enter a character to convert, B, a B is a 2, run again, a lowercase c is also a 2, run again, an M, which we have not implemented, converts to an M. At this point, it'd be pretty darn easy to make it so you could type in an entire sentence and have it converted all to numbers. But we're going to leave that for a later day. That would involve using a while loop. So we would have a, well, I mean, we already have a while loop, but we would have a loop that counted from the beginning of the string out to the end of the string, doing each conversion. All right. Syntax errors. Take all your if statements out now, or at least comment them out. We no longer need that stuff. So, because we replaced it completely. And you can actually delete it if you want, but or you leave it there to look at. All right. Everybody else got it working? Or am I going too fast? If you need more time, that's cool. So if you have a Note 7, are you tempted to keep it? My phone's so cool, I don't want to give it back. I don't know.
iPhone 7 is better.
I like iPhones, but the Notes look like cool phones, so I do feel sorry for them. Okay, so we have seen ifs and we have seen if-elses. A series of if-elses is also known as a cascade. And let's see if I can find a picture of one. If-else cascade. And of course, I'm not going to find one. I'm using Lucidchart, which is a flowcharting program. And so say we were beginning our program and then we've read in our character. Get ch. Then you could have an if statement. If character is equal to an A, except I'm going to do this opposite, then our output is equal to a 1. If that's not true, then we come over here and we have another if. If the character is equal to a D, I'm skipping, B and C. If that's true, then our output is a 2. And if that's not true, we come over here and we're going to have a third one. A, B, C, D, E, F, G. If the character is equal to an F, if that's true, we set our output equal to 3. Else, we just set our output equal to the input. And then somehow we need to hook all these guys back together. So, put a circle down here. That would come straight down here. These two need to hook back up together. Effectively, I'm just going to make them all go to there. Alrighty. Maybe you can see why that's called a cascade. Cascade being like a waterfall, you know. If this case is true, do that. Else if this case is true, do that. Else if this case is true, do that. Else if this case is true, do that. Switch statements are natural replacement for if cascades. Are all sequences of ifs a cascade? No. If-elses are cascades. And I didn't put else on here, but if I was going to flowchart this, then I very easily might feel like tacking on the word else in order to indicate that that's an else if. Not necessary in a flowchart, but that makes it clear. So what do I mean by that? Don't type what I'm going to type in, but what if I had done something like this? And in fact, what our test question was an example of a if cascade. You know, string or int score is equal to 90. If score is greater than 90, greater than or equal to 90, print that you made an A. And surely I don't have to do very many of these for you to recognize it. Else if score is greater than or equal to 80, C out, B, and so on. One more, just for good luck. If score is greater than or equal to 70, C out of C. All right, that's an if cascade because it's a series of if-else ifs. If we left the else's off, this code would not work correctly. If the score was 90, it would print an A, then it would also print a B, and then it would also print a C. So the way to correct that is to add the else statements to it. So to flowchart that would look a bit different. If grade is greater than or equal to 90, then the output is equal to an A. Now I'm going to do this right. Print A. And then you come back here, and you have another one of these. If grade is greater than or equal to 80, print B. You 1113 students are having nightmares of recollection of this stuff. Come on, get up there. Ah, you. Okay, anyways.
What's that?
Print B.
What class was that?
We did this in 1113 last
Was
few
that
semesters.
Intro or?
Intro to.
Yeah, okay.
Okay. And so on. You can see the difference. A cascade, burp, 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 burp. And if you don't put the else's in there, it keeps repeating all the if statements in series. So when you're writing a series of if statements, you just need to kind of remember to yourself, is it a cascade? Do I need else's? This cleanly converts to a switch statement in many cases. This does not convert into a switch statement because you need to do more than one of the things. Yeah, in this particular case, it's a bad program. We should have done it as a with else's, but since we didn't, it would not be a good case for a switch statement. So have we adequately done ands and ors?
Yes.
Okay. You agree? You did and or adequately? Okay. A menu-driven program is one where you display a list of options and then you let them type it in and you do whatever they ask. That's all it means. Enter 1 to delete, enter 2 to do something else, enter 3 to do something else. Validating user input, we've done this. Check to see if input is valid or not. But we are going to talk about validating user input in terms of loops. Oh. I guess this isn't the chapter about loops. Then we won't. Comparing characters. Characters are compared using their ASCII values, which sometimes makes sense and sometimes does not. If you compare two characters, A is less than B, and 1 is less than 2. However, a lowercase a is not less than an uppercase a. Uppercase a is less than a lowercase a. And that's because of the Ascii chart. If you go and look at the Ascii chart, a capital A is equal to a 65. A lowercase a is equal to a 97. So if you compare those two characters together, then it's going to say that this one's less than this one. And in old MP3 programs, you may have noticed that your lowercase names came all after your uppercase names. It would have all your uppercase songs, A through Z, and then your lowercase names would follow beneath. And then how are these things sorted? Well, if it starts with a 0, that comes before an A. But if it starts with a brace, it comes after A. So that kind of stuff may not seem to make sense, but it has to have some order. It has to have some order to go, and the ASCII order is as good as anything if you're using a string. Strings are composed of bytes. There is a different type of string which is composed of what are known as Unicode characters. And a Unicode character is one that allows a far larger range of characters than just this, because you also need to be able to support German and Spanish and Russian and all the different flavors of Japanese and Korean and Chinese and stuff like that. So you have to have a character set which is far larger than just the 255 values that can fit into a single byte. And so there's something called a W string. You can do # include W string rather than # include string if you need to support input from other languages. And then you have a multi-byte character. It's more than one character because, in order to let them type in Klingon, we need more than one byte in order to store those values. So, like characters, strings are compared using their ASCII values. If you have two names, name 1 is equal to Mary and name 2 is equal to Mark, is name 1 greater than name 2? Yes, it is, because the first thing it does is it compares the M's. They're the same. Then the next thing it does is it compares the A's. They're the same. The third thing it does is compare the R's. They're the same. And then it comes down here and, we finally have a difference. Which one is greater, the Y or the K? Well, the Y is greater. So name 1 is greater than name 2. And so name 1 greater than name 2 is equal to true. Name 1 less than name 2 is equal to false. Name 1 not equal to name 2 is equal to true. And here they're showing comparing something, and if the strings are not of the same length, the shorter one winds up being less than the greater one. So here they're comparing name 1 against another string which looks like it matches, but it doesn't really, because this string has additional data. So name 1 is also less than this one, even though they started with Mary. This one's longer, and so it's considered larger. The conditional operator. I meant to talk about this last time, but I don't recall if I did. Did we get to conditional operators?
Question?
That's when you use a question mark and the colon in your expression.
We did, but I don't really remember.
Let's do it again. Alrighty. The way the conditional operator works is it's like a miniature if statement. So say I have a variable called temperature, and it's set to -20. And then I'm going to have another variable, a string, called state. And the state's going to be either water or ice. So I could do this. If temperature is less than 32, or 0 for you Celsius fans, state is equal to ice, else state is equal to water, liquid. Now that's ignoring the fact that, it could be steam or something like that. We could just make it frozen and not frozen, or ice and not ice. But anyways, here's a more concise way of writing that. State is equal to, and then we put our condition. Is temperature less than 32? Question mark. If it is, I want that string set equal to ice. Else, I want that string set equal to water. This one statement means the same thing as these four lines of code. Which one do you like most? That's a personal preference. You'll see a lot of programmers eventually lean towards doing stuff like this. I think that if this expression gets overly complicated, it can make the code more difficult to read. This is a pretty simple example, so after you get familiar with it, that wouldn't be too difficult to read. But like if you had an expression here, rather than just a string, x plus 3 minus 2, and then you had another expression here, y minus p plus k, or whatever, the conditional expression could get very complicated very quickly. Strictly speaking, you don't need the parentheses. You could do this. I think that makes it harder to read. I'd rather see the parentheses there myself. So that's a conditional expression. Why is it called conditional? Because there's your condition. And if that's true, it's equal to the first thing after the question mark. If this is false, it's equal to the second thing after the question mark. Here's our example. Is x less than 0? If it is, then y is equal to 10. Else, z is equal to 20. Then that's doing it different than how I did it. And the Java language does not support it in that fashion. The Java language more supports it in the way that I just showed it. But you can do it that way as well. Both of those work in C++. So if temperature greater than 212, question mark, Cout boiling /n, or Cout not. And I think I've got a mistake here. I think I don't need a semicolon there. Not boiling. /n. I don't particularly like that. I think that that's pretty grungy. But you could do it. What's happening here is that if this expression is true, it does everything before the colon. If this expression is not true, it does everything after the colon. So they're just using this as a sneaky if statement. Why do that? So if I was going to rewrite what they have here, I don't know what I would do. I would probably write it in the form of an if statement. When it's like that, it's pretty clear, but meh. That makes sense. We're all happy with the conditional. We're going to use them every day of our life from now on. Good deal. The switch statement we have now covered. It's used to select among statements from several alternatives. In order for the switch statement to work, what that you're switching on, that variable, ch or whatever, has to be either an integer type or something that can be easily converted to an integer, like a character. A character really is an integer. It's just a very small one. It's just a byte. Floats, doubles, strings, those will not work. Other languages will let you do switches on all sorts of exotic flavors. But C++ wants it to be an integer type or something derived from integer like the character type. So expression must be an integer variable or one that evaluates to an integer variable. And then all the cases have to be constants. You cannot do this. Int boiling is equal to 212. Int freezing is equal to 32. You can't do this. Switch based on my temperature. Case boiling. Do something. Followed by a break. Watch this. It's actually not giving me an error. I'll get mad at it. Okay, now it's underlining. Case freezing, colon, cout, cold, break. The reason it's underlining it is that the case conditions all have to be constants. Now in this case, it's easy to turn it into constants. We could just come up here and add the word const. That makes those errors go away. But the reason for that is that C and C++ is not a scripting language. It's not an interpreted language. It's a compiled language. And for it to properly construct the machine code for a switch statement, it has to know before the program even runs what boiling and freezing are. And if these are variables, it doesn't really know what those values could be. Somebody could change the value of these variables. You know, maybe the switch statement doesn't know what these things are in advance, but if they're constants, it does know. So that has to be an expression, a numeric or a character, an integer or a character. These have to be constants. They can either be literal constants like numbers, 212 or, single quote A, single quote. They can't be variables. We've talked about what the break statement is for. Blocks and scope. The scope of a variable, we've already talked about this, is the block in which the variable is defined. It's usually defined at the beginning of a function, but sometimes you can define, you can define your variables anywhere in that code, but it's quite often people go and declare them up at the top of the function. Get lost. Okay. So up here, I had some variables. I did not explicitly declare them up at the top of the function. Some people would like to see them there. They'd like to see string S up at the very top and string O up at the very top. Get rid of those and do char ch, define that. You don't have to do that. It makes your program look a little bit more structured if you do that, and it's also easier to document. Contains our input string, contains our output. Call this the first character of our input. Now our code is easier to understand, perhaps. We can at least look at it and understand what the variables do. And sure enough, I could have added those comments when it was down here, but it'd be harder to read because it'd be mixed in with all the other stuff. But you don't always have to do that. Like if I had a while loop down here, while s is not equal to, question mark, whatever our while loop was going to be, I might just want to declare my variables inside there. Int sum is equal to 3, that kind of stuff. That's also totally cool. There's no real reason to declare sum all the way up here if all you're going to do is use it inside of a while loop down here. So it's a kind of a balance. Decide, do you want to declare your variables up at the top, or do you want to declare them close to where they're being used? And my rule of thumb is to try to declare them up at the top of the series of braces in which they're used. This one is local, or if this is the only place I'm going to use sum is inside this while loop, then I may as well define it up at the top of the while loop. That's what I try to do. But when I'm demonstrating code to y'all, I just stick variables everywhere. You know, I try to stick them very close to where I use them so that, you know, it's very clear. That's not the way I do it when I'm programming professionally. So the scope of the variable is the block in which it is defined. This variable up here, S and O, is valid from here all the way down to the end while. After that, S and O are no longer valid. They are no longer in scope. If I wanted those to be valid even outside of the while loop, I should move this stuff to the very top of the function, like that. But these variables are only used inside that while loop. So that's why I go ahead and tend to put it there. I don't need this stuff hanging around outside of the while loop. By the time I get down here and I do this stuff with score, that stuff was no longer necessary. We no longer need S and O and CH. So I would prefer to put them up at the top of the code block in which they are used. Usually you define them at the beginning of the function, but you can define them close to their first use. My rule of thumb underneath that would be define up at the top of the block in which they are used, the innermost block in which they are used. Variables with the same name. Some languages won't even let you do this. But you can define variables that have the same name, and then you can confuse yourself. I'll show you what I mean. I'm going to declare a variable here called fun, and I'm going to set it equal to 9, and then I'm going to write an if statement. If fun is equal to 9, then print out yay 9, changing to 11, and then I'm going to do another variable, int fun is equal to 11. And then I'm going to come out here and I'm going to print fun out. What is that going to print out? Somebody may already know. Is it going to print out a 9 or is it going to print out an 11? Looks like it's going to print out an 11, does it not? The way that I just said that makes you know that it's going to print out a 9. The reason for that is that this is actually a different variable than this one. And like I said, some languages won't even let you do that. Java won't let you do it. I don't recall if C# will let you do it or not. This one masks that one. If I print out fun here, it would print out 11. But then once I escape that block of code with that brace, once this version of it is no longer in scope, because it's only in scope inside here, then I'm accessing that one, and it would print out 9. So in this case, it would print out 11, and then it would be followed by printing out a 9. Is that confusing? Yeah, it is. So avoid doing that. Don't declare multiple variables with the same name if you can avoid doing so. Is it okay to do it if they're in different functions? Yeah, totally. If I have a different function down here, int new code, and I want to declare a new variable called fun, that's totally cool. It's in a different block of code entirely. You and I understand that this has nothing to do with that. But this one fakes us out. It makes us think that we are changing the value of that when we are not. This one masks this one so that if we wanted to find out what the value of fun was down here, we can't. This value is no longer available to it, but outside of the block it is. This value is not available outside the scope of it. Down here it's totally cool. What if we wanted the same variable to be available within two different functions? What if I wanted a variable fun that was accessible both within main and in new code? What would I do? And I know one of y'all knows. I could pass it in. That would be a great idea. There's another way we could do it too, and it's a less recommended way, but it works.
Declare outside both.
I would declare it outside of both, which makes it a global variable. I could come up here, declare my fun variable, initialize it with some value probably, not necessary, but just to be safe. Then I don't have to declare it here, and I don't have to declare it there. It's using the same variable in that case. So that variable is being shared between two functions. You're getting kind of close to the idea of object-oriented programming when you do that. But in object-oriented programming, you don't want to make global variables, but you do want to make variables that are shared between a certain set of functions. And that's what's known as a class. And we will be talking about classes pretty soon. Okay, that's the end of that. So what's our homework going to be? Our homework is going to be, it's going to be an easy one. We have some code here for doing the phone numbers. Go away. I'm going to take that code, get rid of that, paste it into a Word doc for those who are not here. And then I want you to modify it so that it supports all the letters, A through Z, not just the ones that we've done already.
So use the same case statements, breaks, stuff like that?
Yeah, you can just use everything you've done so far and just add some cases. Add all the cases in order to support every letter that's on the telephone keypad. So homework, change the following code to support all letters from A to Z according to the telephone keypad. And just for good measure, we'll take that picture and we'll paste it in there.
When does it due?
We'll make this one due Tuesday of next week.
Right before homework.
Is next week spring break?
Fall break?
Fall break?
Yep.
Then it's not due Tuesday. Yeah. Why would I make it due the day before we don't meet? It'll be due Sunday of that week.
Damn, I shouldn't have said anything.
But it won't take that long. I mean,
No.
you can get it done anyway. You could probably get it done in 15 minutes, you know,
Probably tonight.
Were you
tonight. Yeah, or before you leave, whatever.
Were you make a Dropbox for the in-class?
Yeah, I will. Let me make a Dropbox for the in-class stuff that we typed.
Oh, the stuff that we just typed up?
Yeah.
I'll retype that up.
No, don't retype it up. If you've lost it, just
I took pictures of it, but I forgot to save it when I already logged out.
just create a Word doc that says, lost it, whatever.
Yeah.
Alrighty, it's H. And this will be homework 6. Alright, so I'll see y'all next Monday.
if I already modified it to do that, can I just submit
Yeah.
them both with the same file?
Yeah.
I added 2 lines of code to mine that basically,
I knew some people would do that, so.
what I did on mine is I actually had 2 lines of code to kind of error check it to make sure it was
Make sure it was valid. Yeah, that's cool.
I've got some idiot proofing done already.
That's cool. Input validation is a good thing.
It's the worst in C++.
Yeah.
It's really terrible.
Yeah, exception handling in C++ is not nearly as fun as it is in some other languages.
So many functions already built in elsewhere.